इतना क्या डाल दिया? बहुत ज्यादा डाल दिया।
क्या है बास में दुनिया भर का बा।
ये तो सही से बात है, इतना इतना बहुत ज्यादा ही डाल दिया।
वो तो थोड़ा सा डाला।
ये मुंह धो ले, जा मुंह धो ले बाद में, मुंह धो ले पहले शूज। हाँ पता है मुझको, पता है पर धो दे दो।
Good morning, sir.
हेलो सर, गुड मॉर्निंग।
सर आप स्टार्ट कर सकते हैं सर।
स्टार्ट कर सकते हैं ना सर? मेरा आवाज आ रहा है क्या क्लियर?
यस सर, वॉइस क्लियर है सर।
ओके ओके, थैंक यू। Yes students, a very good morning to everyone. Now we can start. I hope you are all fine and doing well. Yes. Yes students, hello. There is no reply from your side. Is everyone good? क्या हो गया इतना सुबह सुबह इतना टेंशन में? So but I hope that I am clearly audible to you all. You are able to hear my sound. सब लोग को मेरा साउंड एकदम क्लियर सुनने को आ रहा है, कुछ प्रॉब्लम नहीं है? ओके ठीक। So better let's start the lecture now without wasting our time. Now today I'm very much confident that we will going to complete the first unit of this chapter. Beta basically this chapter consists of 3 units. Whiteboard दिख रहा है? Beta are you able to see the whiteboard? सब लोग को whiteboard दिख रहा है? Yes, you are able to see the whiteboard. So as I told you, I have started with this chapter. क्या चैप्टर में स्टार्ट किया था? यू नो द नेम ऑफ दिस चैप्टर? कौन सा चैप्टर हम लोग पढ़ रहा है? Anybody knows the name of the chapter that we are learning? Yes. So beta we are learning as per the NCERT textbook, right? And the name of the chapter is that we are learning, it is a motion of system of particles and rigid body. This is what we are learning. So let me just write on the board which chapter we are learning. We are learning the chapter, it is the motion of system of particles and rigid body. Right? But at this chapter we are learning. Now under this chapter, beta ye chapter ke andar there are 3 main units. There are 3 main modules. The first module under this chapter is that is the module number 1, and that is a center of mass. सबसे इसका अंदर पहला है, that is the center of mass, and I'm very much confident that today we're going to complete a discussion of a center of mass. Our center of mass पूरा खत्म हो जाएगा, and then we can start with the rotational motion. Right, and today I'll be able to start with the rotational motion. And then after the rotational motion, the last topic under this chapter is bada wala topic, bada wala unit. It is a moment of inertia. So student, please understand which chapter we are learning. It is very essential for us to know which chapter we are learning. But we are learning the motion of the system of particles and the rotational motion. There are 3 big units in this chapter. The unit number 1 is the center of mass. I think we had a discussion about the center of mass. But हम लोग center of mass का understanding start किया था, right? And then today we shall going to complete all the numericals from the H.C. Verma sir's book plus additional numericals about the center of mass. And I'm very much confident that we can start with the rotational motion. Rotational motion के अंदर हम लोग kinematical equation study करता है. We study what is the moment of force, what is the torque, couple. Those things we learned in the chapter of a rotational motion. And then the last will be the moment of inertia. Am I clear? Am I clear with this? Okay. But at any point of time, if the things are not clear, you feel any kind of doubt, my dear student, देखो मैं always when I'm making a request to everyone, since your feedback is only the response which I can receive. So please see to it that you are giving a true feedback in the chat box. What are the things you are able to understand, you are not able to understand? Please be free and speak. Speak means you can put in the chat box, right? Okay. Now, but if you are able to recollect, we have done the few numericals on the center of mass, and we have said, yes, beta, that will come in this chapter, right? It will come in this chapter. So who has asked this question? Parth, it will come. The rolling part will also come in the rotational motion, that will come. So, but if you are able to recollect, we have done the few numericals, and there was the one very famous kind of a numerical which comes frequently for the entrance exam. हम लोग भी solve किया था, and that was the numerical that if there is a some mass m1 and there is another mass m2, and if m1 is displaced by the some distance, if m1 is displaced by the distance x1 and the center of mass remains unchanged, what is the distance by which m2 should be replaced? So somebody always say that, sir, can you start giving the short trick? So now, but in between, I'll going to give you the short trick, a shortcut methods of solving a numericals, right? So what I've done is I have selected that kind of sum. In fact, I have written that kind of sum. So let me just put that numerical on the whiteboard so that you can start thinking and we can start solving. Fine. So I'll be doing a few numericals initially. Let me just tell my plan for the 2-day lecture. But I'll be just doing some numericals. Oh, to bataya nahi main. Sorry. So let me just tell you my plan for the 2-day lecture. What is my plan for the 2-day lecture? So my very first plan for the 2-day lecture is I'll be starting with the solving numericals, which you'll understand short tricks. This is what the very first thing I'll be doing. I'm just planning to solve around 3 to 4 numericals. And then once these numericals are done, after that we're going to study a center of mass of a rigid body. But we have discussed the center of mass of a point masses, right? But we know that in the practical conditions, there can be the continuous mass. So we must study the center of mass of the rigid body, they having the continuous mass, continuous distribution of mass. Then we are also going to discuss about the motion of the center of mass. And once the motion of the center of mass is done, we can do the numericals related to this. We can end this unit. And after that, I can start with the rotational motion. So this is my planning for the 2-day lecture, my dear students. So let's solve a few numericals. Okay? Okay. Now, before I'll start with the class, I wanted to know that, beta, is there any doubt? Is there any confusion up to this point, or everything is going fine? Do you want any kind of improvement I shall be doing from my end? Okay. So let's see this numerical. Let's see, this is what like somebody were trying to tell, sir, can you start giving a short trick? So now, this is the numerical that you can see on the whiteboard. Let's solve this. And after solving this, beta you can use a short trick जो इसको हम लोग को मिलेगा and that you can apply for any numerical. What they are saying? So what they have given in the sum, in a system of two particles having the masses m1 and m2, the first is pushed towards their center of mass through a distance d. So I can say that there are two masses, beta one mass is m1. One mass is m1. There is another mass that is m2. It is not necessary that the two masses will be equal. The one of the mass is m1, another mass is m2. M1 may be bigger, m2 may be bigger. There is no clear indication, but I'm just taking that the two masses, they are the different one, right? If first is pushed towards their center of mass through the distance d. So one thing is very clear, the center of mass will be here. This will be the center of mass. So I can say this is a center of mass. This will be the center of mass. Now what they are asking, by what distance should the second particle be moved so as to keep the center of mass at the same position? So let us say that this is the origin. The origin is somewhere here. This is the origin O, and the distance of the center of mass the distance of this m1 from the origin is x1. The distance of this m2 from the origin, it is x2. And if x is a distance from the, if x is the distance of a center of mass of the origin, it is then what we have discussed, right? I hope you are able to understand. Are you finding any problem or everything is fine? But I think this is what we have seen. If one mass is m1, another mass is m2. If m1 ka distance is x1, m2 ka distance is x2 from the origin, and if x is the center of mass, then the formula for the x that we have learned, this x can be written as x will be equal to m1 x1 plus m2 x2 divided by m1 plus m2. This is what we have learned in our discussion. So if this is m1 x1 plus m2 x2 divided by m1 plus m2, I can say that let a mass m1 is pushed by the some distance. So let m1 is pushed by distance d1. If m1 is pushed by the distance d1, d1 लिखने का, or you can write a delta x1 if you wish. So let m1 is pushed by the distance delta x1. If m1 is pushed by the distance delta x1 and m2 is pushed by delta x2, So if M1 is pushed by delta x1, M2 is pushed by delta x2, then the center of mass delta x will be M1 into delta x1 plus M2 into delta x2. So this will be M1 delta x1 divided by, plus M2 delta x2 divided by M1 plus M2. What they have said, that the center of mass at the same position. So there is a no change in the center of mass. The center of mass remains at the same position. It means that delta x ka change, that is the center of mass, that is 0. So this will be M1 x1. This will be M1 delta x1 plus M2 delta x2 divided by M1 plus M2. So now I can do the cross multiplication and I can say this M1 delta x1 plus M2 delta x2, this will be equal to 0. And as this is equal to 0, what is the delta x1? They have said the value of a delta x1 is d. So this I can write as d. And as I'm writing d, I can say that this delta x2 will be minus m1 upon m2 into d. But I can use this as the general formula. इसको हम लोग है ना general formula के जैसा use कर सकता है, and I can solve any numerical. Right, I'll give the example also. I'll be giving a few examples. उसके पहला I would like to ask whether you have understood this or not. If you have understood this, then tell me so I can give you some examples. क्या सब बच्चे लोग को ये समझा? समझा तो रिप्लाई करो, समझा नहीं समझा तो रिप्लाई करो नहीं समझा. Repeat the last step. I've not understood. Okay, fine. ठीक है, अच्छी बात है. Now can I get a reply? Who is there? Gitesh. Gitesh and other students, can you give me the reply whether you have understood this part? कि नहीं? If it's a simple सा definition है, if one body is having the mass m1, उसका origin to distance x1, another body is having the mass m2, इसका origin से distance is x2, then the center of mass x is m1 x1 plus m2 x2. इधर तो कुछ doubt है. So let me write this as equation number 1. Are you finding any doubt up to equation number 1? No one. Understood. Okay. No doubt. Fine. अभी क्या बोल रहा है वो देखो. समझो अपन ने M1 को शिफ्ट किया. अपन किसको शिफ्ट किया? M1 को. So I am shifting M1 by a some distance delta x1. If I am shifting M1 by the some distance delta x1, so I am saying that let M1 is pushed by delta x1 and M2 is pushed by delta x2. समझा क्या? If M1 is pushed by delta x1, M2 is pushed by delta x2, so then the change in center of mass. Let me call that change in the center of mass is delta x. Then this delta x will be m1. x1 का place पे I can write a delta x1. m2 का place x2 का place पे I can write as a delta x2 divided by m1 plus m2. क्या इक्वेशन नंबर 2 सबको समझा कि नहीं समझा? इक्वेशन नंबर 2 समझा नहीं समझा? समझा नहीं समझा? जल्दी बोलो. Okay. Now, beta, they have given by what distance should the second particle be moved so as to keep the center of mass at the same position. If the center of mass remains at the same position, so since there is no change in the center of mass, since there is no change in the position of center of mass, there is no change in the position of a center of mass. अगर उसका position change नहीं हुआ, then what is the value of a delta x? Is it 0? So I can say 0 will be equal to m1 into delta x1 plus m2 into delta x2 divided by m1 plus m2. इधर तक ये भी नहीं समझा. नहीं समझा, 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 समझा, समझा. फटाफट बोलो यार, क्या कर रहा है? सब आराम से घर पे बैठ गया यार, सैटरडे एंजॉय कर रहा है. आई वांट द रिप्लाई फ्रॉम एवरीवन. व्हाई अदर स्टूडेंट्स आर नॉट रिप्लाइंग? हाँ, अभी अगर मैं इसको क्रॉस मल्टीप्लीकेशन करेगा, इफ आई डू द क्रॉस मल्टीप्लीकेशन टू दिस, then this will be 0. So I can say 0, it is equal to m1 delta x1 plus m2 delta x2. Or I can write one on the left side, other on the right side. So this will be m1 delta x1, that is equal to minus m2 delta x2. Or what is the value of a delta x2? This delta x2 will be m1 divided by m2 का negative sign means minus m1 upon m2 delta x1. क्या सब बच्चे लोग को ये समझा क्या? ये समझा क्या? समझा क्या? समझा क्या? नहीं समझा, नहीं समझा, नहीं समझा, नहीं समझा, समझा. गीतेश and other students, ये समझा क्या? लास्ट पार्ट नहीं समझा? अरे यार, लास्ट पार्ट इसमें क्या नहीं समझने का था? ये वाला इक्वेशन समझा क्या इधर तक? गीतेश तुमको इधर तक समझा क्या? अच्छा, ये समझा. सो अगर ये समझा तो मैं अभी ना m2 को इधर लेके आ रहा है, ये m2 को इधर लेके आ रहा है, तो ये क्या हो जाएगा? m1 डेल्टा x1 डिवाइडेड बाई m2. बट m2 के पास क्या साइन है? माइनस साइन है. ये क्या हो गया? डेल्टा x2. Therefore, what is delta x2? Delta x2 will be minus m1 by m2 into delta x1. अभी भी नहीं समझा? बोलो. समझा? समझा? Okay, I received your reply. Thank you so much. अभी देखो, अभी I can tell you, look at this example. Okay. So let's look at this sum. By what distance the mass m1 is shifted? So they have said the mass m1 is shifted by the distance d. So delta x1 is shifted by the distance d. So if delta x1 is shifted by the distance d, what should be the value of a delta x2? This delta x2 will be minus m1 upon m2 into d. माय डियर स्टूडेंट्स, बेटा मुझे बहुत अच्छा लगेगा अगर अगर मैं आप लोगों से रिप्लाई रिसीव करेगा कि क्या सब बच्चे लोग को, मेरे बच्चे लोग को इधर तक समझा क्या, एकदम क्लियर हो गया? पक्का 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 ओके, क्रिस्टल क्लियर हो गया? ठीक है, चलो इसको नोट डाउन कर लो, फिर मैं इस पे एग्जांपल्स देता है। नाउ व्हाट, अच्छा मैं एक चीज लिखना भूल गया, what is the meaning of this negative sign? But the meaning of the negative sign is once you are moving m1 towards m2, this m2 you are moving towards m1. So this m2 you are moving towards m1. So this delta x2 is towards m1. So I can say the negative sign shows that the mass m2 will move in opposite direction. The mass m2 will move in the opposite direction. So when I'm just making a full screen, once you are done, you can give me the reply done karke, so that I can give you some examples, oral questions based on this. Other students, please reply. जल्दी जल्दी बोलो। ये जल्दी बोलो यार, हो गया क्या? Done, all of you are done. मैं वेट कर रहा 1 मिनट के लिए, बस ज्यादा वेट नहीं कर पाएगा। ओके ठीक है, चलो नाउ लेट मी गिव यू अ फ्यू एग्जांपल्स बेस्ड ऑन दिस। ठीक है, वैसे सब बहुत सारा एग्जांपल्स आएगा, इसको ना शॉर्ट ट्रिक करके ये फॉर्मूला को याद रखो। If there are two masses, one mass is m1, another mass is m2. If the mass m1 is shifted by the distance delta x1, and the mass m2 will be shifted by the distance delta x2 in order to keep a center of mass same. And this shift of a delta x2, it will be equal to minus m1 upon m2 into delta x1. You should remember this short trick. You can solve a number of numericals based on this. There may be the question like this way. If one mass is 10 kg, I'm just giving a few examples. तुम लोग खुद example बना सकता है बेटा. If one mass is 10 kg, if there is a mass having the 10 kg and the another mass is 20 kg, so ऐसा question बनाएगा. There are two objects, one is having the mass 10 kg, other is having the mass 20 kg. They are separated by the some distance. If the mass m1 is shifted, or if the mass m1 is pushed by the distance of the 2 centimeter, what should be the shift in the mass m2 such that the center of mass remains same? जल्दी बोलो कितना आंसर आएगा? एकदम सिंपल सा क्वेश्चन है, कितना आंसर आएगा? This delta x2 will be minus 10 by 20 into 2. What is minus 10 by 20? Minus 10 by 20 कितना हो गया? Minus 1 centimeter. It means that the mass m2 should be moved by the distance of 1 centimeter towards m1. There can be another example. I can take another example. If there are two masses, one mass is the very heavy mass, which is having a mass of 100 kg. There is another mass m2 whose mass is, let's say, only 1 kg. If this mass m2, it is shifted by the distance of a 10 centimeter, then what should be the change in the mass m1 such that the center of mass remains same? फॉर्मूला इधर अपने पास है, इधर यही फॉर्मूला है. तो अगर अपने को डेल्टा x1 कैलकुलेट करना है तो बच्चे लोग क्या हो जाएगा? इट विल बी माइनस m2 डिवाइडेड बाय m1 इनटू डेल्टा x2. व्हाट इज माइनस m2? बेटा माइनस m2 इज -1, m1 इज 100 एंड डेल्टा x2 इट इज 10. डरने का नहीं है, डरने का नहीं, डरने का नहीं. What is 1 by 10? 1 by 10 is minus 0.1 सेंटीमीटर. क्या ये किसी को नहीं समझा कि 100% एकदम क्लियर हो गया? कोई भी टेंशन नहीं है, कोई भी लफड़ा नहीं है, कोई मन के अंदर डर नहीं है, कुछ नहीं है, सब क्लियर है, एकदम माइंड पक्का क्लियर हो गया. कैन आई गो टू द नेक्स्ट क्वेश्चन? अभी क्या ये शॉर्ट क्या आएगा? 100/1 कैसा आएगा यार? फॉर्मूला देखो गीतेश, फॉर्मूला देखो. डेल्टा x2 का फॉर्मूला क्या है? माइनस m1 अपॉन m2 इंटू डेल्टा x1. सो डेल्टा x1 क्या होगा? माइनस m2 अपॉन m1 इंटू डेल्टा x2. क्या हो गया? अरे बट अभी इसको शिफ्ट कर रहा है ना गीतेश. गीतेश गीतेश फॉर्मूला देखो. गीतेश फॉर्मूला में क्या बोला है वो देखो. फॉर्मूला क्या है गीतेश? डेल्टा x2 is minus m1 m2 into delta x1. So can I say delta x1 will be minus m2 upon m1 into delta x2. m2 कितना है? 1. m1 कितना है? 100. 10 0 0 कैंसल. 1/10 is 0.1. गीतेश समझा? ओके. सो आई थिंक यू आर ऑल डन. क्या मैं थोड़ा सा एक ट्रिकी सम सॉल्व कर दूं क्या? ट्रिकी तुम लोग के लिए नहीं है. अच्छा दुनिया बोलता है ट्रिकी है, पर तुम लोग के लिए एकदम सिंपल रहेगा. दुनिया इसको ट्रिकी बोलता है, बट मैं तो ट्रिकी नहीं बोलता हूँ. ठीक है, चलो चलो सब लोग बोलता है ना ये वाला सम को सर ये बहुत ट्रिकी है, ऐसा सम ना समझ में नहीं आता है। जब भी एग्जाम में ऐसे टाइप का सम आता है तो बच्चे लोग हो जाता है कंफ्यूज, बट आई नेवर गेट कंफ्यूज। आई से ये तो कितना सिंपल टाइप का सम था, राइट। सो मैं वैसा टाइप का एक सम आप लोग के सामने बोर्ड पे रख रहा है। कैन यू सी दिस सम? थोड़ा बड़ा करूं क्या? ऑल ऑफ यू आर एबल टू सी दिस सम माय डियर? ये आज कम लोग आए हैं क्या? नो, 48। टुडे द स्ट्रेंथ ऑफ द क्लास इज लेस। स्टूडेंट्स आर नॉट हैप्पी, दे आर नॉट एबल टू अंडरस्टैंड। क्या यार, कुछ भी दिख रहा है सब क्वेश्चन? आई थिंक यू आर हैप्पी, यू आर एबल टू अंडरस्टैंड। क्यों लोग पब्लिक, अच्छा सब लोग आया है? ओके, आई थॉट दैट आज कम लोग आया है। ओके, आई फॉरगॉट इन द बिगिनिंग, my all dear students wish you a happy Shiv Jayanti. Okay, fine. Then now let's look at this question. ऐसा कोई कोई बच्चे लोग बोलते हैं ना सर ऐसे टाइप का क्वेश्चन ना हम लोग सॉल्व नहीं कर पाता है, ऐसे टाइप का क्वेश्चन हम लोग को डाउट आता है, हम लोग का दिल डर जाता है ऐसा क्वेश्चन देख के। तो उसमें दिल डरने का कोई बात नहीं है। Should very much confident. What they have said, a thin uniform flat plate. There is a thin uniform flat plate of the mass 4.5 kg is in the shape of the L-shaped lamina. मतलब there is a letter L. ऐसा लेटर होता है ना L. कोई प्लेट है, सर क्या ड्रॉ किया, मैं ऐसा ड्रॉ किया, कोई there is some letter L alphabet का शेप में there is a one plane. Right, so there is a plane lamina in the letter of L alphabet. Correct, as a letter, you can see this. Right? Okay. And they have a mass of the 4.5 kg. इसका पूरा mass is 4.5 kg. बच्चे लोग, in this mass of 4.5 kg, what I can see, this is the one part. This 4.5 kg, my dear students, what I can see is this is the first part. This is a second part. And this is the third part. There are three parts. So I can say that they can be considered as a square. So each part, it is like a square. So this each part, it is like a square. It is like a square. It is like a square. So each part is like a square and they have a equal mass. So there is a square of a equal mass. Right? What is the equal mass of the square? Beta, the total mass is 4.5 kg. So this will be a 4.5 kg. And how many squares I could see? 3. So I can say they have a mass of the 1.5 kg each. Therefore, the mass of each block therefore the mass of the each block, I can say M1, it is equal to M2, that is equal to M3. This will be equal to 1.5 kg. The mass of the each block will be 1.5 kg. समझा 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 कुछ रिप्लाई नहीं आया यार, क्या है समझा. So if better they have given here C1 is the center of mass of the first का center of mass is C1, second का center of mass is C2, and third का center of mass is C3. So the C1, C2 and C3, they are the center of mass. So the C1, C2 and C3, they are the center of mass. I want to write the coordinates of a C1. बेटा इधर तक है ना, दिस इज अ 4 सेंटीमीटर, इधर तक 4 है, तो क्या इधर तक 2 होगा और इधर तक 2 होगा, तो क्या इधर तक 1 होगा. इधर तक 4 है, this is 4, so this is 2, so this will be 1. So can you tell me what is the coordinates of C1? C1 का coordinate x1 will be 1 and y1 will be 1. 1 comma 1. Similarly, if I am writing the C2 ka coordinate, then it is 2 up to this point, and this will be a 3. But this y-axis will be 1. So this x2 will be 3, y2 will be 1. If I want to write the coordinate of a C3, then this x1 will be 1, x is 1, and this y is 3. So x3 is 1 and y3 is 3. Before I'll proceed ahead, I would like to receive a reply whether everyone has understood up to this point, then only I'll proceed ahead. जल्दी से reply करके मुझे बताओ. सब लोग समझ गया? Okay, there is no problem. All have understood. So now I can write the x coordinate of the center of mass. What is the formula for the x coordinate of center of mass? M1 x1 plus M2 x2 plus M3 x3 divided by M1 plus M2 plus M3 divided by M1 plus M2 plus M3. Therefore, this x will be equal to 5 by 3. Yes, एकदम 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 मस्त मस्त मस्त. ऋषभ मजा आ गया, ऋषभ मजा आ गया. So M1 is 1.5, M1 is 1.5, X1 is 1. Yeah, this is what is the advantage. This is what I want you to work with me. ऐसा नहीं मैं सिर्फ सॉल्व करेगा, तुम लोग आराम से घर पे बैठ के चाय बिस्किट खाएगा, right? What is M2? M2 is 1.5 and this X2 is 3. M3 is 1.5 and this X3 is 1 divided by M1 plus M2 plus M3. So 1.5 plus 1.5 plus 1.5. This is a 4.5. ये देखो, this is 1.5, this is 4.5 and this is 1.5 divided by 4.5. So 1.5 plus 4.5 plus 1.5, this will be a 7.5 divided by 4.5. So 7.5 divided by 4.5 will be a 5 by 3. Now if I want the center of mass for the y coordinate, then this y will be M1 y1 plus M2 y2 plus M3 y3 divided by M1 plus M2 plus M3. Now this M1 y1, what is M1? M1 is 1.5 and y1 is 1. So this will be 1.5. M2 is 1.5. Y2 is 1. So this will be a 1.5. M3 is 1.5. M3 is 1.5, but Y3 is 3. So this will be a 4.5 divided by M1 plus M2 plus M3. This is a 4.5. So this is coming out to be same. So this is a 5 by 3. Everyone has understood this or not? Yes. So this is here. Explain the sum again. Yes, I'll explain. Who has asked this question? Can you explain this sum again? Yes, Anushka. I'll explain. Beta ध्यान से सुनो Anushka. Then after that, if you're not able to understand, I'll resolve it. Anushka बेटा क्या आपको L shape में दिख रहा है इधर? Can you see this L shape? बेटा this L shape को they have divided into a three equal parts. So if beta the total mass is 4.5 kg and each mass is equal, so can I say this 4.5 kg is divided into a three equal parts. So each part ka mass will be 4.5 by 3, which is 1.5. Anushka, just reply if you have understood this. Yes. Now, so beta each block is having the mass of 1.5. Concentrate to the block 1, बेटा जिसका सेंटर ऑफ मास C1 है, ये वाले ब्लॉक को कॉन्सेंट्रेट करो जिसका सेंटर ऑफ मास है C1. अगर दिस फर्स्ट ब्लॉक x एक्सिस में 2, y एक्सिस में भी 2, तो बेटा इसका सेंटर will have the coordinate 1 on the x-axis and 1 on the y-axis. So I can say for C1, the coordinates are 1 and 1. Similarly, if I'm looking at C2, beta this C2 is along the horizontal axis, which coordinates will be a 3 along the x-axis and 1 along the y-axis. So 3 along the x-axis, 1 along the y-axis. Then I'm writing for the C3. So C3 ka coordinate is 3 along the y-axis and 1 along the x-axis. But just give me the reply, Anushka, if you have understood the coordinates wala part. Then I'll proceed ahead. Beta coordinate wala any point if you are not able to understand, I'll resolve. Nothing to worry. Clear? Okay. So beta now what is the formula for the center of mass? Beta the formula for the center of mass is m1 x1 plus m2 x2 plus m3 x3. ये formula है ना center of mass का. बेटा अगर ये formula है center of mass का तो क्या होगा वो देखो क्या होगा. m1 का जगह पे 1.5, x1 का जगह पे 1, m2 का जगह पे 1.5, x2 का जगह पे 3, बेटा m3 का जगह पे 1.5, x3 का जगह पे 3 लिख दिया. फिर क्या देखा लिखने के बाद divided by m1 plus m2 plus m3. So 1.5 into 1 is 1.5, 1.5 into 3 is 4.5, 1.5 into 1 is 1.5 divided by 4.5. So 1.5 plus 4.5 is 6. 6 plus 1.5 is 7.5. 7.5 divided by 4.5 is same as 75 by 45. Now you can read the table of 9. It comes out to be 5 by 3. Exactly same procedure we have followed for the y center of mass. For the y center of mass, it is m1 y1 plus m2 y2 plus m3 y3 divided by m1 plus m2 plus m3. But I'll be very happy if I can get a reply from you. You have understood this absolutely clear, 100% clear. I'm very happy with the student, those who are replying, right? Understood. Okay, chalo. Shall I proceed? I hope you are all done with this. I can go to the next sum, and after the next sum, I can go to the center of mass of the continuous body. Chalo, beta, can I take a next sum? Okay.
पैसा नहीं का तो
पैसा नहीं तेरा
बहुत है सपना
जितना पॉसिबल हो रहा है ना, आई एम नॉट यूजिंग अ पीपीटी टू टीच यू, नाइदर आई एम जस्ट यूजिंग अ पीडीएफ टू टीच यू. आई एम जस्ट ट्राइंग टू डेवलप अ कंसेप्ट इन फ्रंट ऑफ यू लाइक अ रेगुलर classroom teaching. Correct? ये देखो. The two bodies of the masses 2 gram and 10 gram have the position vectors. Position vector means, I need to draw a diagram. I'll tell you. So let us say this is the x-axis, right? This is the x-axis, and there is a y-axis. Z-axis भी चाहिए. This is the Z-axis. So there is a one body जिसका mass is m1, and there is another body, वो xy plane नहीं, xyz में रहेगा. There is another body with mass is m2. So what is the position vector? The position vector r1, it is a 3i cap plus 2j cap minus k cap. And the position vector r2, it is I minus j plus 3k. What they are asking, find the position vector and distance of the center of mass. So we have to find the position vector and the distance of center of mass. I shall be doing both things. बेटा सबसे पहले तो क्या find out करना है? I have to find out the position vector, right? So we know what is the position vector of the center of mass. The position vector of the center of mass is r. It is m1 vector r1 plus m2 vector r2 divided by m1 plus m2. This is the formula. So what is m1? This m1 is 2 gram and m2 is 10 gram. So this will be 2, right? R1 is 3i plus 2j minus k plus m2 is 10. So it is I minus j plus 3k divided by m1 plus m2. So 2 plus 10 is 12. So this will be 3 into 2. This is a 6i cap. 2 into 2 is 4j cap. And 2 minus 2k cap. Plus 10i cap minus 10j cap plus 30k cap divided by 12. So what I can see, this is a 6i and 10i. What is 6i and 10i? 6i and 10i, this is 16i. This is a 4j and 10j plus 4j minus 10j. So this will be minus 6j. Minus 2k plus 30k. So this will be a plus 28k divided by 12. I can take 2 common. Why only 2? Yes, I can take only 2 common. If I'm taking 2 common, then this will be 8I cap minus 3J cap plus 14K cap divided by 12. So this becomes a 6. So this will be 8I cap minus 3J cap plus 14K cap divided by 6. Right. So this is the position vector. Now, if I want to calculate the magnitude of this vector, we all know how to find out the magnitude of the vector. So, beta kya hoga? This will be the 8 by 6 ka whole square plus minus 3 by 6 ka whole square plus 14 by 6 ka whole square. The 6 ka square I can take out. This will be 1 by 6. This 8 ka square, this is a 64. 3 ka square, this is 9. And 14 ka square, this is 196. So this comes out to be a 2.73 unit. I hope everyone has understood. I'll feel very happy if I can get a quick response from you whether the things are clear. Please, 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 please. रिप्लाई करो चैट बॉक्स में, क्या पक्का क्लियर हुआ, क्या पक्का क्लियर हुआ, क्या पक्का क्लियर हुआ, क्या पक्का क्लियर हुआ. All done. डन डन. प्लीज प्लीज फटाफट रिप्लाई करो. डन. ओके. ऑल डन. Okay, chalo, I can proceed ahead now. अभी नहीं, 5 मिनट के बाद ब्रेक लेते हैं यार. We'll take a break after 5-10 minutes. ठीक है, चलेगा ना? क्या हुआ? Okay. So now with our next topic that we'd like to study, जो अपने को अभी study करना है, the next topic. Just a minute, I'll just drink a water. Just a minute. Thank you. Okay. So now, beta, we have to start with the next topic, that is a center of mass of a rigid body having the continuous distribution of mass. So let's start with this topic, a continuous distribution of mass. So the center of mass of a rigid body having the continuous distribution of mass. Okay. So let's start now. Till now, what we have discussed that there are the point masses, one mass m1 having the distance x1, another mass m2 having the distance x2, and so on. And then we wrote a center of mass. But beta, whenever we see any rigid body in very practical conditions, suppose karo, this is what the rigid body we'd like to see. This is the rigid body. The moment I'll see this rigid body, what I can understand is, but this rigid body doesn't consist of a point masses. There are the continuous masses. You may say that there is a one body, its mass is a delta m1. There is another body, its mass is a delta m2. There is another body, this mass is a delta m3. It means that the rigid body doesn't consist of a point masses. There are a continuous masses inside a rigid body. The one mass is attached with the another mass. They are not isolated one. So what we have done is, beta, we could write a formula for the center of mass for the discrete masses. जब ये लोग अलग अलग था, but in the reality there are no discrete masses, right? In the reality there are no discrete masses. बेटा discrete masses नहीं है. There are no discrete masses. Okay, there are the continuous masses. And if the masses are continuous, how to write a center of mass? So in order to write the center of mass, I can say that let a rigid body consist of continuous masses let a rigid body consist of the continuous masses. One continuous mass is delta m1. There is another mass delta m2. There is another mass delta m3 and so on. There is another mass delta mn at the locations x1, x2, x3 and so on xn respectively. Then I can write the coordinates of the center of mass. Then the coordinates of the center of mass x can be written as a delta m1 into x1 plus delta m2 into x2 plus and so on plus delta mn into xn divided by this will be a total mass which is m1 plus m2. So this will be m1 plus m2 plus and so on plus mn.
निकल ही रहा था बात इमेज के साथ लिंक था ना इमेज के साथ लिंक इमेज
Right. So this will be the m1 plus m2 plus and so on plus mn. What I can do is I can write this x, the center of mass x will be a summation from I equal to 1 to n delta mi xi divided by a summation from I equal to 1 to n of mi. Now the summation from I equal to 1 to n mi, this is the total mass, right? This is the total mass. And how I can write? I can write this will be equal to. Okay, so let me just create a space. I'm in the process of creating a space. No space. So this will be equal to a summation from I equal to 1 to n delta mi xi, and this will be a summation from I equal to 1 to n. This will be mi. Now, I would like to ask one simple question from you all. Beta, can you see the rigid body on the right side? Beta, that rigid body has many masses. Matlab, jo delta m hoga, are they large in number or they will be the small in number? So the number of particles will be small or the number of particles will be large. Correct. Very good. So the number of particles are large. But as the number of particles are very large, correct? Can we say that delta m will be small? Can we say that delta m will be small? I will give you the example. Let us say that we are distributing the one big. We are distributing the one big pizza, one big pizza, into 100 students, the students will going to get a big part of the pizza or the small part of the pizza? बोलो फटाफट. The students will going to get a small part of the pizza. That's correct. That is absolutely true. So I can write a rigid body. So for a rigid body, beta, for a rigid body, this n is very large. I may say tends to infinity. And if this m is very large, which is tending to infinity, then this delta mi, it is very small, maybe close to zero, not zero. In that case, I can write the center of mass x will be a limit delta mi tends to zero. Summation from I equal to 1 to n delta mi xi divided by summation from I equal to 1 to n of delta mi. I'm sorry, I done one small mistake. I should write delta. Okay, and this, beta, we all know that this is nothing but the integral. So this is the integral of x dm divided by the integral of dm. What is the x? X is the distance of the particle dm I do not know if all my dear students, they have understood this. क्या बेटा ये सबको समझा? Can I get a quick reply whether all of you have understood this or not? Yes, last part nahi samjha. Last part I'll explain you. Beta, whenever we are doing a summation, right? देखो इधर limit say. This will be learning your integration. Your teacher will going to teach you in this part. But basically, the integration and the summation both are same, right? If you are adding the small parts, then that is called the summation. But if you are adding over a surface, then that is called the integration. So this summation, I'm just replacing by the integration. Nothing else I'm doing. So I'm saying that for the continuous mass, the center of mass will be the integral of x dm divided by dm. I hope you have understood. Gitesh, should I explain you in detail or it is okay? Okay, ठीक. So this x can be written as the integral of x dm divided by the integral of dm. Now, what is this integral of dm? Beta, this integral of dm, it is nothing but it is a total mass. This is the total mass. and this total mass, it is equal to m. So I can write the x coordinate of the center of mass will be the integral of x dm divided by the total mass. Similarly, I may write the y coordinate of the center of mass. I may write the z coordinate of the center of mass. So I can write a similarly, y coordinate of the center of mass will be y dm divided by m. And the z coordinate of the center of mass will be the integral of z dm divided by the total mass m. So let vector r, if it is a position vector, if a vector r, it is a position vector, then I can write this position vector of a center of mass will be a vector r dm divided by m. If they are at origin, then that will be 0. So I will just request you all that you can note it down now. And once your writing is done, we can take a break for 5 minutes. And after the break, we can study the motion of the center of mass. Okay. Okay. So you can note it down and you can tell me reply done karke so that we can take a break for 5 minutes. Done? Okay. All of you are done? Yes, I'm waiting for your reply. Yes, but the screen is there. You're not able to see the screen. I hope you can see the screen. Okay, so let's have a break for 5 minutes. I'll be coming back in 5 minutes.
फिर से नींद में सो गए तेरे को बोला था खोला करने को खोला कर जा दुरुस्त कर अभी उसका
पापा ने मेरा फिर से नींद उड़ा दिया यार इतना अच्छा सपना नहीं देखने देते आप अच्छे से एक भी
मैं सपना अभी पूरा कर दूंगा खत्म चल
हाँ
धोने मुंह फटाफट इधर है उधर है दो बेटा फटाफट दो मुंह धो के पानी पी लो ना देगा कहीं बात मारना बंद हो जाएगा
क्या करना है बांस नहीं मारेगा तो
पेट खराब होता है और कुछ नहीं क्या करने कुछ नहीं समझा मुंह धो लो एकदम साफ हो जाओ ये बड़ी वाली भी ऐसी है पड़ी रहती ये लगी थी कर ले बुर्श कर ले फटाफट चलाई
क्या है हाँ अरे आप बैठ गए मेरे गुदड़ियों पे
नहीं मैं नहीं बैठा
अरे मैं नहीं बैठा क्या
तो तुम नहीं बैठा
Why few student they have left? क्या हो गया?
थोड़ा आगे हो जाओ।
वो लोग को लगा ब्रेक में भाग जाने का है क्या?
हाँ आगे हो जाओ। कौन सा सीट? गाड़ी का। अरे यार गाड़ी का सीट के खराब थोड़ी है। खराब है आपका नहीं, पीछे से दिख रहा है, आगे से भी दिख रहा है। उधर है इतना तेरा। अरे आप ऐसा ना करो, हो जाओ। तू जा पहले वो ये कर।
Yes, we should start. I am here only.
साइकिल के नीचे रख दे इसको। इतना माफ कर लीजिए।
चलो स्क्रीन शेयर करता हूँ
पे बैठो।
and then we can start.
अरे इतना खेलता। दांत ब्रश कर जब।
Yes, why? Please, the lecture is not end. Don't leave. लेक्चर अभी तक चालू है, अभी तो इम्पोर्टेंट पार्ट पढ़ने का है, ठीक है? इट इज जस्ट फॉर यू, जस्ट हैव अ 2 मिनट्स में फटाफट चलो, राइट? मैं साइड में रख देता है, दोज हु वांट दे विश दे कैन हैव, ठीक है ना? यस, प्योर 100%. हाँ, यस यस, एंजॉय एंजॉय द फूड.
अरे चालू करके जब
शिव जयंती यार. Okay, now beta we're going to learn a very very important topic now, the motion of the center of mass, the last topic of this chapter. तो छोटा सा है, कंजर्वेशन ऑफ लीनियर मोमेंटम, वो पढ़ेगा अपन.
नहीं होएगा।
लेट्स स्टडी अ वेरी वेरी इंपॉर्टेंट. जो लोग इधर भाग गया उन लोग को बोलो आ जाए, लेक्चर अभी स्टार्टिंग ज्वाइन कर 9 o'clock को किधर भाग जाते हैं मालूम नहीं, ठीक है? दिस इज अ वेरी वेरी इंपॉर्टेंट टॉपिक, द मोशन ऑफ द सेंटर ऑफ मास.
कभी नहीं निकलता,
You should not
ऐसा हो ही नहीं सकता।
miss a single point, right? ठीक है, ठीक है, रेडी? Hey, are you ready और अभी क्या हो गया? Okay, चलो, let's start. So now I'm starting this a very important topic. But this is the motion of the center of mass. अच्छा, नेटवर्क का इश्यू है कॉलेज. ओके, ठीक है. The motion of the center of mass. See, I have no problem. I can take a class from 7 to 9 also. कुछ कॉलेजेस है क्या? अच्छा, ओके, कॉलेजेस है इसके लिए. ठीक है, ठीक है. I will discuss with sir. And let's see if it is feasible. I can plan. ठीक है. I can plan. Okay, so we can proceed now. So what is the motion of the center of mass? I can say that now let us consider n particles. Consider a large number of particles. But let us say there are n particles having masses m1, m2, having masses. One is having mass m1, other is having mass m2. हो गया ना खाके अभी सब लोग का हो गया. Typical 100% Maharashtrian. Right? So one is having the mass m1, other is having the mass m2, and so on, having the mass mn at position vectors. So they have a position vectors. So they have a position vectors. One is having the position vector r1, but second is having the position vector r2, and so on. The position vector is vector rn. हम लोग क्या लिखा? The center of mass, this vector r, can be written as the m1 vector r1 plus m2 vector r2 plus and so on plus mn vector rn, divided by m1 plus m2 plus and so on plus mn. This is what we have done. And then we said this m1, m2, m3 and so on mn, because they are nothing but this is the total mass. So if this is the total mass, what I can do is I can equate, and in place of this I can write a total mass capital M. So if this is the total mass capital M, I can write this will be the m1 vector r1 plus m2 vector r2 plus and so on plus mn vector rn, divided by the total mass m. As I'm writing this is equal to the total mass m, beta this will be m into vector r. Cross multiplication kiya, m into vector r, this is equal to m1 vector r1 plus m2 vector r2 plus and so on plus mn vector rn. बेटा पूरा ना मैं आपको थियरी भी पूरा पढ़ा दे रहा है. I am not only solving the numericals and the MCQs, but my dear student, I am teaching with the entire theory. Correct? अगर आप इतना theory भी पढ़ा, so it will be more than sufficient. Correct? पूरा theory आपको पढ़ा दे रहा हूं यार. भी और क्या कर सकता हूं? So now, if I'm going to differentiating equation 1. बेटा अगर हम लोग इसको differentiate करेगा ना, then this will be m. m का derivative नहीं होगा, m constant है. This is the derivative of a vector dr by dt. m1 is constant, there is a derivative of a dr1 by dt. plus m2, there is a derivative of a dr2 by dt, plus and so on. This will be mn, there is a derivative of a d vector rn by dt. Can somebody tell me what is a rate of change of displacement? What is this? Beta, what is the rate of change of displacement? Velocity. So this dr by dt will be the velocity center of mass. This dr1 by dt will be the velocity v1. This will be the velocity v2. This will be the velocity. So this will be the velocity vector v1. This will be the velocity vector v2. This will be the velocity vector vn. So I can say this m into the velocity of a center of mass m into vector v, this will be equal to m1 vector v1 plus m2 vector v2 plus and so on. This will be mn vector vn. Yes or no? So I have got the equation in terms of velocity. समझा सबको? सबको समझा? Any problem? Any doubt? Any problem? Please tell me. बेटा सबको समझा? Have you all understood this without any confusion? No confusion, no problem. सब लोग को समझा है, वेरी गुड। अभी इसको एक बार और डिफरेंशिएट करेगा। सो इसको एक बार वापस से डिफरेंशिएट करेगा। सो डिफरेंशिएटिंग इक्वेशन 2, if I'll differentiate equation 2, then this will be m, this will be a derivative of velocity with respect to time. This will be m1, this will be a d by dt of a velocity v1, this will be m2, this will be a dv2 by dt plus and so on. This will be mn, this will be a dvn by dt. What is the rate of change of velocity? Because the rate of change of velocity is nothing but the acceleration. So I can write this as ma. This dv by dt is the acceleration a. This dv1 by dt, it is the acceleration vector a1. This is the acceleration vector a2, and beta this is the acceleration vector an. You're going to find the importance of these discussions as you start solving the questions. Jitna aage jaoge na, whatever theory I'm teaching, you will find कि sir हमारा तो concepts एकदम clear है, and we are able to understand the question 100%. You'll find the advantage of these things when you start solving the questions and you start revising. So this will be the m vector a. Beta, what is the bada wala a? Bada wala is the center of mass. So m vector a can be written as m1 vector a1 plus m2 vector a2 plus and so on. This will be mn vector an. mn vector an, right? Now can somebody tell me what is the Newton's law? What is the Newton's law? Second law. F is what? What is F? F क्या होता है? What is F? What is F? F is ma. So But if F is ma, force it is equal to the mass into acceleration. If force it is equal to the mass into acceleration, right? Then what will be M1A1? Can I say this M1A1 will be equal to the force F1? This M2A2 will be equal to the force F2, and this MNAN will be equal to the force Fn, yes or no? So I can say this total, this M into A can be written as a vector F1 plus vector F2 plus and so on to vector Fn. Right? Let me call this as equation number 3, and this is equation number 4. So let vector F is the total force. If vector F is the total force, then this can be written as a vector F1 plus vector F2 plus and so on plus vector Fn. And hence, I can write M into vector A will be equal to the vector F. Right? समझा कि नहीं, पहला सर को बताओ, क्या इधर तक सबको समझा कि नहीं? अप टू इक्वेशन नंबर 5, उसके बाद में आगे बढ़ेगा। जल्दी से बोलो, क्या सबको इक्वेशन नंबर 5 तक समझा? क्या सबको इक्वेशन नंबर 5 तक समझा? क्या कुछ भी डाउट आया, कुछ भी टेंशन आ रहा है, कुछ डर लग रहा है? डर रहा है? डर लग रहा है कि हैव अंडरस्टूड? पक्का? ओके, समझा। Wait, just wait. Now what will happen? बेटा, this total force कोई भी सिस्टम में, if I'll say, then this total force F, it is always the sum of two forces. Right? The total force F, it is always the sum of the two forces. It may be the some external force that is acting on the body, or it may be the some internal force that is acting on the body. Right? So you can say that this M vector A will be equal to the external forces plus internal forces. But whenever I am talking about a rigid body, correct? Then we know that from the Newton's third law of motion, if one body is applying the force on the second body applies the force on the first body. So their forces are equal and opposite. so it may get cancelled. So I can write the external force that is acting on the body. This is equal to the mass into center of mass of acceleration. What is A? A is the center of mass of acceleration. So, but I have made a full screen. You can just tell me, then I can go to the last part, which is the conservation of a linear momentum. If you have understood, just give me the reply. If you have understood, your writing is done, then you can give the reply done karke. Understood. I'm very happy that you give a reply that you have understood. So if you're done, you can give the reply done karke. Done. Okay. Yes, beta, we have 5 minutes, and as I told you, in 5 minutes, I'll be able to do. I can do this in 5 minutes. So the conservation of linear momentum let's discuss about this conservation of a linear momentum. So let us say that there are the mass m1, there is another mass m2, there is another mass mn, and they are moving with the velocities a vector v1, then there is a velocity vector v2, and so on. There is a velocity vector vn. So we know what is the momentum. Then this total momentum P can be written as the momentum of the first body, P1, momentum of the second body, P2, and so on, the momentum of the nth body, Pn. What is P1? The P1, it is nothing but m1 vector v1. This P2, it is m2 vector v2, plus and so on. This will be mn a vector vn. Right? So this will be the. Now we know what is the Newton's third law of motion. If I want to differentiate this, so let's differentiate. अगर हम लोग इसको differentiate करेगा, so what we'll get? This will be a dp by dt. Mass is constant, right? This will be a d by dt of m1 vector v1 plus m2 vector v2 plus and so on plus mn vector vn. Now what is the rate of change of momentum? The rate of change of momentum is the force, in fact the external force, right? Now if I'll say if the external force is 0, it means no force is acting on the body, then this 0 will be equal to a d by dt of m1 vector v1 plus m2 vector v2 plus and so on mn vector vn. And but if the derivative of this term is 0, so I can say that this m1 vector v1 plus m2 vector v2 plus and so on plus mn vector vn, this is equal to a constant. So this is what it says, that if no external forces is acting, then the total linear momentum remains constant. Then the total linear momentum remains constant. And if you are able to recollect what we have done earlier, so what we have done earlier, this m into v, it is m1 v1 plus m2 v2 2 plus mn vector vn. Right. So if this is a constant, let me call this as equation number 1 and this as equation number 2. But this is constant. So from 1 and 2 I can write this m into vector v. If this comes out to be a constant, then I can say the velocity is a constant. It means when there is no external forces acting, then the center of mass moves with a constant velocity. In case no external forces acting, then the center of mass moves with a constant velocity. I hope all my dear students have understood this without any kind of confusion. With it now 9:30 and we are about to end the class. Now the time has come that you can submit a feedback if you wish for any improvement in the lecture, or if the things are going fine, then also you can reply. Yes, just but I am preparing the homework. I'll be sending to your in charges soon. Just give me some time. I was so busy this week, and in fact the next week there are, yes, so just any feedback that you would like to submit, or things are going fine. I'll be giving homework. Just give me a little, just some time. Okay. Okay. Everything is fine. Okay, that's great. Chalo. So I can end the class. Bye everyone. Take care. God bless you. I'm just leaving now. Okay. Bye.